All right, excellent. So thank you everyone for coming. This is one of our monthly open houses for the Commonwealth Wind Project. We are here at the Osterville Village Library and also via Zoom. We'll get started. So just a few housekeeping items. Again, this meeting is being recorded. This meeting is taking place via Zoom and here at the Osterville Village Library. At any point during the presentation, folks on Zoom can ask a question either by raising their hand or submitting a question to the Q&A button, which should be at the bottom of your screen. We're going to run through a brief overview of the project and then focus on our discussion topic tonight, which is duck bank safety, and then one or two more updates, and then we'll get into Q&A. All right, Pat, do you want to take over?
Well, hello to everyone on Zoom. I think everybody here in the room, folks had more exciting plans tonight, which is good. But we're happy to be here, and we'll get started, give a brief overview of the project here. So with us in the room is my colleague Rachel Lake, who you just heard from, and our team at Stantec, Ken Fitzgerald, senior principal there, and my name is Pat Johnson, external affairs manager for the project. Also on Zoom is Ken Kimmel, our vice president of offshore wind development, and have a couple other of our colleagues on Zoom as well. And I do want to just go back here. They're also on Zoom, and we'll introduce him later, is Mark Stobart, who's a cable specialist for Stantec with us as well. So just a brief overview of our projects. There you see on the image here, there are 3 projects in the Massachusetts area, south of Martha's Vineyard in Nantucket, that our company is involved in. The Vineyard Wind 1 project, which is currently ending its construction within the town of Barnstable, and is going to be starting offshore construction soon for that project, and is going to start supplying power to the grid later this year. That's a joint venture project that we own 50% of. And then the Park City Wind and Commonwealth Wind projects we own outright. The Park City Wind project is an 800 megawatt project planned to land under its power cables under the Craigville Beach parking lot. And we're here to talk about Commonwealth Wind plan to land its cables under the Dowses Beach parking lot and proceed through the village of Osterville and Marston's Mills into West Barnstable. There's a little bit of detail for those who might be new about the Commonwealth Wind project. This is a 1,200 megawatt project. The hope is for the operations of this project to be completed by 2028. You see some other information there as well. Hope sometime maybe in 2025 start construction for that project within Barnstable. This is a little bit more detail on the project. With this amount of power, it would provide power to approximately 700,000 homes in Massachusetts, the equivalent of taking about 460,000 gasoline using vehicles off the roadways, and also equivalent of taking about 2.35 million US tons of carbon dioxide out of the atmosphere. And the job creation of this project is considerable within Massachusetts. We have components of this project all across Massachusetts. That's why literally this is the Commonwealth's project, because it's benefiting not only Barnstable and Cape Cod in our region, but also other parts of Massachusetts as well. With that, I would like to call up Ken Fitzgerald from Stantec, and I just want to give a brief bit of introduction, the folks on Zoom and for the recording. At our meeting last month, there was a number of questions about the safety of the duck bank infrastructure and the safety of electric vaults that folks had. And we committed at that meeting that at this meeting in May, we would focus on the safety of the duck bank infrastructure. And that's what we're here to do tonight. So I'd like to introduce 2 people. So Ken Fitzgerald is going to speak first. He's a senior principal at Stantec and is a longtime engineer with decades of experience in above and below ground power transmission projects. And he especially focuses on project management. And also with us tonight on Zoom is Ken's colleague, Mark Stobart, who is a project engineer with Stantec, and he's really a specialist in cable projects. And Mark has experience in building underground cable transmission projects around the world. So we hope with both of their expertise and information, you'll find it helpful to hear this information. So I'll turn it over to Ken.
All right, thank you very much, Pat. Just to get the team grounded, we thought we would start off by sharing some photographs. This is actually elements of the Vineyard Wind 1 construction, which, as Pat had indicated, is virtually complete. The depiction is of the underground electrical duct bank. So the duct bank itself is essentially how the cables will be routed. It's concrete encased. Within the concrete encasement, there will be PVC, polyvinyl chloride conduit, and it will be through those conduit that the cables will be routed. Approximately every half mile, there's an underground splice vault, one per circuit. The duct bank you see actually had 8 conduit because the Vineyard Wind 1 project was 800 megawatts. For Park City Wind, there's actually going to be 12 conduit, 9 of which will be active and 1 will be spare. Duct bank safety. There's a lot in the news that has been advertised regarding failures or events pertaining to underground transmission. Underground transmission has been around for decades, not just in the United States, but worldwide. An important thing to note is that not all underground electrical transmission systems are created equal. They're all in for different purposes. Of the reported events that have been identified through the industry, problems are more susceptible in low voltage systems for several reasons. One is because they're not subject to the same quality assurance and quality control procedures that would be invoked on high voltage systems, such as we have on the Commonwealth Wind project. And additionally, they typically do not contain continuous system monitoring features, which would allow the early identification of any type of concern, any kind of abnormality that would therefore trip the system. Many of the vaults that have had concerns as well have been where they contain switchgear or electrical distribution equipment. The dilemma with those is that they typically, over time, will add circuits. Those circuits can become overloaded, and some of the failures that have occurred in the past have been as a result of overloading. I remember several years ago living in a neighborhood where they kept expanding the street. They kept knocking trees down, putting in new developments, new houses, and every single time additional circuits were plugged into the vaults. So that's an example of how that can happen. Issues have also occurred on aged infrastructure that have been around for decades, that were built and designed to what are now antiquated codes. Another important point to note is that this is a big topic within the electrical transmission industry. The various industry associations, whether it's IEEE, and we'll talk about them in a second, they monitor what's going on within the industry. They gather lessons learned. They become aware of issues. They develop subcommittees and issue white papers. And the lessons learned and best practices work their way into the updated codes and standards. And certainly on the Avangrid projects, we are following the latest codes and standards that exist as we do our work. So duct bank safety is not a one and done through the engineering phase and then we forget about it. It's something that's pervasive through the entire life cycle: engineering and design phase, manufacturing, construction and testing, operation, and preventative maintenance. We invoke a very strict system of quality assurance, quality control, QA/QC throughout the life cycle. And we implement state-of-the-art technologies, and we maintain a very keen awareness to ensure we provide a high quality and safe system. A couple of important issues to note as they relate to the failures that we had mentioned earlier is that for the Commonwealth Wind vaults, they're only for cable splices, that there's no switchgear, there's no distribution equipment, and there never will there be any additional circuits added to those vaults. So it's a static design. It's a one and done. I'd like to next walk through the various phases of the project, as we had just mentioned on the previous slide. So for engineering and design, we're utilizing state-of-the-art, well-proven technologies throughout everything that we're doing. We'll also note that the system includes solid dielectric cables, which are not oil filled. The transition vaults, again, are only for splices. No equipment or no switchgear or distribution equipment will be located in them. We've maintained and are implementing a keen awareness to the latest codes and standards that reflect the best industry practices and lessons learned. Some of the codes include IEEE, which is the Institute of Electrical and Electronic Engineers, the National Electric Safety Code, Occupation Safety and Health Administration, OSHA, and there's many others as well. We have a very conservative design. The design team and all the equipment suppliers are designing the project for what's called a 100% capacity factor. What that means is that the project will be at full load, 100% power, 24 hours a day, 7 days a week. And the reason that's conservative is that the expected annual average capacity factor will be actually closer to 50%. Will there be times where the turbines will be running at full bore? Sure they will, but it will not be for a sustained period of time, weeks and months on end. The other key point within the engineering and design phase is safety by design. We have a very coordinated design. We don't have the cable engineers running differently than the duct bank engineers, et cetera. We're integrating the design of the cable, the duct bank, the splice vaults, and we believe that this results in a safe installation as well as safe operation and maintenance over the long term. During the manufacturing phase, we're only working with qualified vendors, soliciting bids from qualified vendors that have a successful track record for this type of cable. And all of them have ISO 9000 level quality programs. ISO is the International Organization for Standardization. It's a worldwide recognized organization, and they issue a quality management standard that everybody is measured up to. So we're certainly implementing those level of programs through the manufacturing process, certainly. In addition to that, cables will undergo strict testing to ensure compliance with industry standards and best practices. And that is a key witness point for both Avangrid and their engineers. Just by way of reference, the photograph below is the old Brayton Point power plant. And what you see there is a graphical rendering of the future Prismium cable. Prismium is going to provide the offshore cable for this project. During the construction and testing phase, again, a very close collaboration between the cable side of the house and the duct bank side of the house. The cable contractor, the person that will actually pull the cable and splice the cable, will be resident at the job site, witnessing the duct bank and vault construction to ensure that the cables could be safely and properly installed. The duct banks themselves will undergo rigorous cleaning and inspection before the cable installation, and then they'll be tested to ensure that there was no damage occurred during the shipping, the handling, the installation, et cetera. Cable splicing is critically important, and we're going to pay keen attention to that as the splices are made. We're going to use fully qualified staff, and we'll be proceed in strict accordance with the manufacturer's recommendations. We're going to implement an extensive field quality control program to ensure that the installation is in accordance with engineering drawings. And then at the end, there will be a comprehensive site acceptance testing program, which of course will include the important splices and terminations. During the operation and preventative maintenance phase, the system has some very key design features. It has a SCADA system. What SCADA stands for is Supervisory Control and Data Acquisition. What it does is it continuously monitors the system for any type of abnormalities or faults. That's 24 hours a day, 7 days a week. So it's always under surveillance. The design also includes protection and control system, and those are redundant. So for any function we have, we've got two of them. So if there is any kind of issue, we've always got a backup, kind of similar to what's done in a nuclear plant. And what those systems do is they will trip immediately if any abnormality is detected. So what that means is the electricity will instantaneously stop. And then again, a key thing over the long term, the transmission system will not be expanded. What is now hopefully a 1,200 megawatt project is not going to become 1,600. And then finally, there will be a robust inspection and maintenance program that'll be conducted by Avangrid, utilizing trained staff over the long term. So that's my presentation. I'll turn back to Pat.
Thanks, Ken. We're just wrapping up here. as we showed before, we have a commitment for long-term to the village of Osterville and to the town of Barnstable, not only for this project, but for 3 projects that we're involved in. So we have a commitment that for this project and all 3 projects, we're going to leave the route, the roadways, and the community better than we found it. We aim to be good partners with the town of Barnstable and particularly with the village of Osterville, good neighbors, finding ways to help mitigate the inconveniences and the annoyances of this construction activity that we're proposing. We have a commitment to fund several village-specific benefits in Osterville and are, as always, looking for feedback and ideas if folks have for those. And if we do choose one of the 2 preferred routes, or what's called the preferred route, one of the 2 route options, and go up Wayano Ave, Main Street through the part of the village center, we will offer mitigation funding to the businesses that we're going to impact, particularly the food service and retail businesses that depend on in-person traffic, to help offset their financial losses from the construction activity associated with our project. And we're doing the same thing in the village of Centerville and Main Street for businesses that will impact for that project as well. Next meetings, we're going to be on Zoom in June. We'll be here likely at the tent, under the tent outside on Thursday, July 19th, here at the Osterville Library, if we have good weather. So hope to see you then. And then we will be again Thursday, August 24th here in the library and also on Zoom. I will note for the July meeting, just folks who are on Zoom watching, we're going to try to make that Zoom if we're outside, just subject to us figuring out the technology and the internet service out on the lawn. We will Zoom that and stream that if possible. But we got some work to do on that once we get closer to that July date. And I do just want to say all those dates you can always find at commonwealthwind.com/events. If you're looking for the next dates, this is my contact information and Rachel's contact information here on the screen. And if you're looking for frequently asked questions, more details, you can always find that at commonwealthwind.com/Barnstable. And let's go to the Q&A. We have
I can take it here, but
okay, great.
I don't know, Hector, if you, the folks in the room, if you want to start us off, you're more than welcome to. Okay. So we have 2 questions that have come in from the Q&A. The first is from Robert Myers, and the question is, are any cooling functionalities included in the duct banks? Please describe.
The duct bank and the vaults do not include a cooling system. As we've mentioned in earlier presentations, the cables operate at a maximum temperature of 194 degrees Fahrenheit. That's 90 degrees Celsius. And then from there, the heat dissipates. It dissipates through the jacketing of the cable, through the PVC conduit, through the concrete of the duct bank, through the thermal backfill, through the soil. So per se, there really is no cooling system that were implemented. And I'll also note that means that there's no extraneous fluids flowing in and around the duct bank or the associated cable.
This might be for you as well. So this is also from Robert Myers. Is there currently a cable Latin process underway off of Dowses? If so, is that coming into Covell or Dowses Beach?
Cable what?
Laying.
Oh, laying. Sorry, laying with a cable laying process.
Yeah, I can take that. Yeah, so the only cable laying activities that are no longer off of Covell's Beach, there was cable laying activities in the earlier end of winter months, early spring months off of Covell's Beach. You could see the vessel, especially in the winter, off of Dowses Beach on the horizon. That was doing 2 things. There was a vessel that was doing the installation of the cable under Covell's Beach that for the Vineyard Wind project under the infrastructure that had been set up the year prior in 2021 and 2022. And then there was also the laying of the cable underneath the seafloor from under Covell's Beach out about 40 miles south to south of Martha's Vineyard, where the project's actually being constructed. So if you saw a vessel at night, you could see it lit up on the horizon. In the winter, that was for the Vineyard Wind project. There's nothing nothing anywhere near the coastline or in the sort of Centerville Harbor, Dowses Beach area. We don't have any vessel work planned off of any of the beaches in the coming weeks or months. And if we had anything scheduled, we'd bring it to community and give a notification. But yeah, nothing else in terms of marine activity in the future that we have right now.
Great. We have one more. Shadi, can you please describe the cable monitoring system used to monitor the health of the cable?
Yeah, we'll let Mark Stobart address that, please.
Sure. Hi, everyone. Can you hear me?
Sir.
Yes.
Yeah. You able to come off camera, Mark, or no worries in that?
Yeah, sure. Hi, everyone. I'm Mark Stobart. As was mentioned, I'm a project engineer with Stantec, and I specialize in high voltage cable systems. So the question there is associated with the monitoring systems for the cables. As was mentioned by Ken, there's protection and control systems that would be monitoring the voltage and the current on the cable system. And if there's any sort of abnormal operation, it would trip the system, i.e. meaning that the electricity would be shut off. And there's also the SCADA system as well. There's other various monitoring systems that can be employed for cable systems, which are currently being investigated by the project team as well to employ in the future.
Great, thank you.
I have a follow-up from Mark.
Sure, Mark, you got Hector Gunther here in the room, is gonna ask you a question.
Do you have microphone? Mark, can you hear me?
Yes, I can. Hi.
Okay. You mentioned that if there's some abnormality, that the system would trip and the electricity would shut off. Where is the shut-off point?
So in the substation, there's circuit breakers. Essentially, there's circuit breakers, there's disconnect switches, and the protection and control system is also within the substation location typically, and those circuit breakers are tripped at that point.
All right, so, but the electricity is still coming through the cables, through the vaults at the beach, through the 6.7 miles of underground power. So the cables underneath the streets of Osterville and West Barnstable would still be live, right?
So I believe there's also shut-off points at the wind farm as well. And that's not my location of expertise. Perhaps someone else may be able to.
Right, we have, there's two substations for the project.
Out in the ocean.
One in the ocean, there may be three in the ocean, and then there's also one on shore. On both ends, there are circuit breakers. So the electricity would be terminated. And I think, Mark, the methodology would be, I believe it would be to terminate all of them at both ends of the cable, would it not?
Correct. Yeah, you want to completely de-energize the cable system.
Right.
So you have 60 wind turbines and they're spinning and you have a default message. Where does all the power go that's being generated by those 60 wind turbines? If you cut the circuit breaker, the power's got to go somewhere, right? It's still being generated.
It's not going to the beach. It's not.
I understand that.
Right.
Where's it going?
Ken, wouldn't we lock the turbines in that instance from the control center?
Most likely, right?
Say that again.
We would lock the turbine blades. I believe, Hector, I'll confirm this with our operations and maintenance team, but I believe we would lock the turbines from the project's control center building.
Right, and suspend generation.
And the people who are monitoring this, where will they be located?
For the Commonwealth Wind Project, that is proposed to be at a secure facility in New Bedford, Massachusetts.
What about Park City Wind and Vineyard Wind?
The current proposal would be that all three projects would be controlled from that facility in New Bedford. That was a commitment made as part of the Commonwealth Wind Project.
Okay. I have a different question. You're awfully precise. You're not Ken,
I'm Ken.
you're Ken too. You're awfully precise about the maximum temperature of the cables. What's the source of that? 194 degrees Fahrenheit precision.
Right, and the precision is actually Celsius. It's 90 degrees Celsius, and
Right.
engineers are calibrated. It's the metric system. That is the maximum allowable cable temperature per the manufacturers for sustained operation, 90 degrees C. The cable could actually operate at a higher temperature, but we don't encroach on that. We use that as the upper cap to ensure that the cable will never exceed 90 degrees. So 90 degrees C is what they're designed for. 90 degrees is the maximum temperature that they will ever see. They could actually go further than that, but it's capped at 90. That makes
So
sense.
say it's a hot summer day,
Right.
a lot of wind out on the ocean. The turbines are going full tilt.
Right.
What mechanism or what engineering system caps the temperature at 90 degrees Celsius?
We're designed for it. We're designed for it. Let me tell you what we do. At 100% load, what we have done is we have done geotechnical investigation, which evaluates many parameters affiliated with the soil down to a fairly deep point. One of the parameters is temperature. So we have a series of, I guess they're called thermistors, that have been peppered along the duct bank route to monitor
They're
temperature.
called what?
Thermistors.
How do you spell that?
Oh, cool. I'm afraid you're gonna ask that. Let's see. Thermistors.
Or Mister?
Thermistor, yes, sir. So for Vineyard Wind 1, Park City Wind, and now it's being done in Commonwealth, we'd send a geotech engineer to take the readings. And we came up with the maximum experienced ground temperature. So what we did is we ran our computer programs. One of them is called CYMCAP, CYMCAP. And what that does is it modeled the ambient temperature during summer. It modeled 90-degree core temperature of the cable, and we're designing to match that condition 24/7. So we're designed for it, I guess, sir, is the short
Okay.
answer.
And forgive me if I get this confused, but 3 400 megawatt cables coming in from offshore dowsers.
Right.
That is spliced into 9
Yes, sir.
cables. What is the diameter of each of those 9 cables?
Sure. They're between 3.5 and 4 inches. They've not been purchased yet or designed by the manufacturer, but roughly 3.5 to 4 inches.
Will those be this, is that the same cable that is coming in from Vineyard Wind?
They'll be conceptually similar to what we have on Vineyard Wind. Generally with Vineyard Wind 1, the subsea cable, which has the 3 circuits all in 3 phases all in one, is roughly 11.5 inches in diameter.
Right, and you brought a model. of
Yes.
that cable.
Yes, indeed.
Right,
So in the transition joint bays at the beach, that gets that 11.5 inch diameter cable gets spliced to 3 cables, each of which is roughly 3.5 inches in diameter.
and that's the technology used for Vineyard Wind, if you're familiar with that.
Very familiar with it. We
Yeah.
were the engineer on that. Yes, the 3 projects are conceptually similar. Will the sizes be exactly the same? Probably not, maybe not. Vineyard Wind was 230 kV, Park City and Commonwealth are 275.
And the kilovolts refers to the each cable underneath the street.
Yes, sir, that's correct. So
So Dow's 9 275 kilovolt cables.
that's correct. We're transmitting from the offshore substation at 275, so that 3-core cable is running at 275 kV. It stays at 275 when we transition to what we call the upland cable. And then through the duct bank, those are all 275 kV circuits.
And the 90 degrees temperature, it's kind of great that I have the floor to myself. The
Sure.
90
We have one
degree-
question at some point.
The 90-degree temperature, I think you referenced the core.
Right.
So that 90 degrees is at
The copper,
center?
the copper,
The
yeah,
copper.
the copper or the aluminum, whatever gets used, the conductor
Okay.
material.
I could provide a little bit more context there as well. So
Mark, why don't you
the-
jump in? Thank you.
Sure. So that 90 degrees Celsius that we're talking about, where that ultimately comes from is it's the operation temperature of the insulation material that's wrapped around the conductor itself. So that 90 degrees Celsius, if if that temperature, if the cable operates above that temperature for a prolonged period of time, then the characteristics of the insulation material can start to change ultimately. But you know, there's different cable ratings. So 90 degrees is the continuous operating temperature, but there are shorter durations where it can go above that. So 105 degrees is like the emergency operation temperature, etc. But our designs are always done towards the 90 degrees to make sure that it's conservative.
Right.
So the maximum temperature can go above 90. Is that what you're saying, Mark?
Only for a short period of time. But 90 degrees is the continuous maximum operating temperature.
Then a short period of time is defined as what?
In the standards, in the industry standards, it's about 15 minutes.
And what happens if you get to the end of the 15th minute, then what?
So it's taken as an average over the overall design life of the cable system, ultimately. So in the standards, there's guidelines saying how long you can operate it for, how often you can operate it for that. But like I said, the design of the cable system is to the 90 degrees.
Okay. And again, just to be clear, the cables coming in and spliced in the vaults at Dows's Beach, there will be 9 of them after they're spliced.
Correct.
And maximum temperature of each will be 90 degrees. Is there any reason why some cables might be hotter than others, or?
No, in fact, when we ran that modeling, we ensured that it would never be more than 90. When we were designing the duct bank, the types of concrete we're going to use, the spacing of the conduit, how close they are and all that, we ensured that it would not go above 90. And it was an iteration. You make a pass, something's 92, that's no good, it's 91. We're below 90.
Okay.
Yeah.
So 9 cables, can you, Mark or Ken, can one of you sort of describe for me how they're arrayed in the concrete duct bank? And then the dimensions of the duct bank, and then the thicknesses of the thermal concrete duct bank. And then finally, what exactly is thermal concrete? How is that different from concrete?
Well, first of all, thermal concrete is designed to dissipate heat. It's designed to try to keep the cables on the cooler side. The duct bank itself is 4'6" high. 4'6" high. Okay, I'm sorry. Let me answer. Start at the beginning. It's three conduit wide by 4 conduit high. So 3 across, 4 down for a grid of 12. Why do we have 12 versus 9? We have a spare conduit for each circuit. Each circuit has 3 live cables. And what we've done for each circuit is installed a spare for potential future use if it was ever needed for any kind of cable replacement or anything. It's a standard protocol to design accordingly.
Okay, I'd like to come back to that, but keep
Sure.
describing the duct bank.
Sure.
The dimensions and the thickness.
3 conduit wide, 4 high. Okay. The height is 4'6" inches.
So that's the external height,
Right.
top to bottom.
Top to bottom.
Okay.
Right. And then the width is 8'2" inches. That's 8'2" inches. And what that includes, that actually includes the margin for the thermal concrete. So the way the duct bank was modeled is we have the duct bank proper, and then we put the thermal concrete on the side of it as well to help dissipate the heat. But instead of utilizing that as 2 different pores, we're going to do it as 1 pore. So the combined total width, the maximum width, is that 8'2" that I had mentioned.
8'2".
8'2" inches.
Okay. And those again, the 4'6" and 8'2", those are the external.
External dimensions, and right,
Okay.
nominally the depth is about 3.5 feet.
And the width is 8'2".
8'2".
But yet you only have 3 cables arrayed And how far apart is each cable in the group of three?
I should send you a drawing. I don't want to give you the wrong information. We
Okay.
could easily send you a drawing. In fact, it's public information. It's in our EFSB filing. We'd be happy to send those to you.
Okay, can you give me where, do you know where in the EFSB filing, just? Because I've got that on my computer, I think.
Okay.
If not, I can look for it and then,
We could set you in the right direction.
Okay.
I could email them to you.
okay, all right, these guys have my email.
Perfect.
But again, what I'm coming back to is 3 cables by 4, so three,
Three conduit.
no, cables, we're talking cables now.
Okay.
And you say 3 here, 3 here, 3 here, they're arrayed on top of each other.
Well, no, I can see any of this,
Okay,
but it's gonna look something like this.
And after this question, I think we have a couple more coming in,
please,
so we'll take one.
yeah, I don't.
Yeah, no worries at all.
This is a side view of the duct bank.
Okay, and then there's
Each one of these is a, sorry, it's 4.
yeah, and then there's a 4th.
Right. So that's
And-
what it looks like.
And 8'2" between, well, on the outside between here.
Right.
Yeah. And you say the cables are 2 or 3 inches in diameter, something like that.
That is correct. Okay, so that's roughly what it looks like. And this is the ground.
Right.
Okay. We're roughly, on average, 3.5 feet deep.
All right, so the surface of the roadway to the top of the duct.
That's correct. Now, not every one of these conduit has cable in it. The cables are strategically placed to balance the heat and also minimize EMS. Very, very detailed studies were taking place. I mentioned that SimCat, which addresses the heat. My colleague Chris Long and I, and my team, worked together to strategically place the cables to offset EMF effects. And so those are the two key criteria designing the duct bank, is to minimize the heat and also balance out the EMF. Those are two of probably many criteria, I should say.
And I'm sorry to go back to this. The width or the height is 8'2", the width. Okay. And that term you use, SimCap, CYM-CAP.
Yes, sir. It's
Okay.
a software. It's a
Okay.
software that our electrical engineer, Mark could probably, I'm sure could describe it way better than I could.
Yeah, essentially, there's something known as ampacity studies, and that's essentially what this program is used for. So ampacity is essentially a fancy word for meaning how much electrical current can you push through the cables to make sure that that temperature isn't exceeded. So it's a software ultimately to do that. And out of that software, we can use it to figure out what the conductor size should be for the cables, what the cable spacing should be, the burial depth. And these studies are done at all aspects along the entire cable route.
So one of the rows of 3 cables will be dormant, right? Or you got a total of 12 cables and it's 3 by 4. Will each of the 3, will one row of the 3 be not live, or will they alternate?
There'll be 3 dormant conduit in the duct bank. They're not in a specific row. They were basically optimized to basically balance out the system by way of ampacity, temperature, and EMF. We could send you something to show you where they're located. I can tell you this, the bottom row is not empty.
Okay,
They're kind of.
right, that makes
around.
sense
Yeah,
because it's furthest down.
exactly.
So the bottom row would be roughly 7.5 feet from the top, from the road surface.
Yeah.
Okay,
Okay.
but you say you have 12 cables, but
Not 9 cable, 12 conduit.
9 cables, 12 conduits. So what exactly is the conduit? I thought the conduit was the box, the thermal box.
Yeah, let me just show
The
you.
concrete box.
Oh,
around
we
it.
get
I can
the,
pull the slides back.
yeah, if you would.
You looking for that first one?
Yeah, the
Those
very
pictures?
first one on the
Yeah.
duct bank safety. It's not complete,
And
but
and Rachel, if you wanna, And let somebody else in.
Yeah, absolutely, Pat. It's pulled up on my laptop right there. There's a question.
Yeah. Let's see. So Ellen has a question. What strategies do you plan to employ to protect the beach, the spit, the estuary at Dowses Beach, and the resident and migrating wildlife, and to protect the aquifer that is shared by everyone on Cape Cod? So I'm happy to take a start at this. Thank you for the question, Ellen. So we'll start with what are we going to do to protect the estuary and Dowses Beach generally, the wildlife. We are going to keep the operations of the horizontal directional drilling within the paved surface of the parking lot. We are not going to, construction will not veer into the protected resource areas, into the marsh and the wetlands, into the dunes. We're going to keep the operations only within the paved parking lot. So whether it's the sort of entrance channel into East Bay or East Bay, and the other protected resources areas surrounding the parking lot at the beach, we're not going to have any operations in those. In terms of protecting wildlife, certainly we'll avoid nuisance to wildlife by staying within the beach parking lot, but we're also going to need to comply with strict guidance and permitting requirements, especially from the Massachusetts Office of Endangered Species. Can't remember what NHESP stands for, but there's an office particularly that protects endangered species such as piping plovers and other endangered species. Roseate tern is another one. So we will have be in full compliance with any of that and have observers on site within the parking lot when we're doing construction activity as required or appropriate. So hopefully that helps your question. I think there was a third part of that question, Rachel, if you don't mind.
Yeah.
That I don't recall.
The aquifer.
The aquifer, that's a good question. So we focused on this, Ellen, back at a meeting, I believe in February, and we can send the link to our February open houses on the YouTube page for the Osterville Village Library. But essentially there's been some conversation, especially when we had a federal review by the Bureau of Ocean Energy Management. There was some comment period where there was questions about would any of the drilling activities for our project going on 40, 50 feet below Dowses Beach and under the parking lot, is there any way that drilling activity could compromise the aquifer in Barnstable and in Cape Cod, any public drinking water wells or private drinking water wells? And so at the time, BOEM answered that question, and they, from their experts, said that our drilling activities would not be deep enough to have any impact on the Cape Cod drinking water source aquifer. We then had our hydrologist from Ken's team at Stantec speak to this, and Ken gave a presentation at our February meeting where we went into that in a little bit more depth. And essentially came to a similar conclusion. There's no risk here to the aquifer, and it's important to note that the aquifer on Cape Cod is not a bubble. It's not like there are two distinct underground water bodies of salt water and fresh water that, if pierced, would meld across the Cape or even in the general area of Osterville. That doesn't work that way. And the findings of that study by our hydrologist were essentially that there is no risk of any compromising of the aquifer in the Osterville area from this drilling activity off the beach. So hope that answers your question.
Suzanne Conley is next to Dr. But I don't know if Hector, you want to kind of keep going a little bit, or Suzanne had a question as well.
Go ahead,
Okay.
Suzanne.
Great. Suzanne, I'm going to take you off. Just give me one moment.
Oh, yeah, can I I'm gonna go put the Zoom back up here so we can see Suzanne. Gosh, I can't see how to. Where did the Zoom go? Oh, no, maybe stop sharing. That would help. There we go.
Yeah.
Okay, Suzanne, I don't know if you can.
I got it.
Oh, you got it here.
Yeah.
Okay.
All right, Suzanne, you should be able to unmute.
I did click on mute.
Yep, we can hear you.
Can you see me?
Because it's a webinar, I don't believe you can turn your camera on in this
Oh,
setting.
all right. Well, I honestly did not know that the focus tonight would be on the safety of the underground electrical vaults. So I have a few questions there, maybe two, but I also had a much more general question, if I could follow up with that. Is that okay?
Sure, go ahead. Yeah.
All right. So my understanding is that about 600 underground electrical vaults smoke, burn, or explode in this country every single year. I also understand that of all these underground utility vaults, only 30% of the ones that do explode or catch fire or smoke are electrical vaults. So not the majority of them, the minority of them. And of the underground vaults that do have that sort of catastrophic failure, 5% of them involve high voltage electricity being generated. So I understand that that's a small percentage of the problems. So my first question is, can you guarantee that there would never be such an event in one of the vaults at Dowses Beach?
I'll take that, and Ken or Mark, please add. I think I know you asked me this question at last month's meeting, Suzanne.
But we're
Well,
focusing on it tonight, so I wanted to bring it back to the table, Patrick.
Absolutely. Yeah, thank you, Suzanne. So no, we cannot make an absolute guarantee of that nothing, no failure could ever happen to our infrastructure, nor could any utility project or gasoline, propane, any fossil fuel or electric type project make an absolute guarantee. But I think, as Ken Fitzgerald showed in his slides tonight, we have extensive protections and monitoring that are state of the art and of the highest quality to monitor our infrastructure to prevent any type of failure of the infrastructure from happening. But can I guarantee absolutely nothing, no type of failure would ever occur? I could not make that commitment.
Okay, and so if one of these things happens at a substation or in a remote area, it's one thing, but on a bathing beach with kids running around in bathing suits in a parking lot that is packed with cars on a hot summer day, I would say that you're putting them in the wrong place, especially with one narrow means of egress off of that beach. But we'll leave it. Thank you for your answer, Patrick. I appreciate it.
Of course.
I also read, as I've been investigating all of this, as I'm sure you can tell. I also read that one of the reasons for failures in splice vaults, and that's what we have here, involves intrusion of water. And as we've mentioned many times, this entire parking lot and the causeway are underwater, completely underwater, under flowing salt water, 2 to 3 times a year without fail. So what mechanism will be in place to ensure that there will be no water infiltration? There would be no water infiltration into your proposed underground electrical vaults.
That's a great question. So I'm gonna ask Ken Fitzgerald and to answer, and maybe Mark as well. Thank you.
Sure, thanks, Pat. Yeah, Mark, I'll start. You could finish. Yeah, a great question, Suzanne. We acknowledge the conditions out at Dowses. We've seen the photographs from, I think it was December 22nd. The system is designed for underwater service is the short answer. The cable, the splices. So we've addressed it in that manner, and that's not particularly unusual, particularly for the offshore wind market where there's always a beach landing. Mark, I don't know if you have anything you'd like to add to that.
No, I think you covered it well. There's industry standards, and typically for these types of projects, the standards in the technical specification, those standards are listed, and that the cables will be able to be submersible. So there's a wide variety of submarine cable projects around the world that have been installed for many years with good reliability. So it's something that's
So just to follow up with that, the subsea cable is your export cable, your offshore cable. Once that cable is spliced, you're talking splices, and that's where the faults, that's where the arcs happen. And I'm not sure, because I'm not an engineer, but the fact that cables are spliced makes them much more susceptible to arcing and having problems. And I'll just leave it at that. I'm sure you wouldn't agree that it's a danger, but hello, okay, my phone rang, sorry. But I'll leave it at that. I had one final question about the vaults, and then I'd like to go on to my general question, if that's okay, Patrick.
Please, go for it.
Are the 90 degrees Celsius heat being generated by the spliced cable? So in other words, I'm now talking about the 3 cables that are together in each of the underground vaults, and that, you know, with their 6 friends will form the duct bank. So there'll be 9 of them, and they each emit 90 degrees Celsius heat, and is that heat cumulative?
So I can talk about that. So one point that Ken had brought up there during his earlier presentation was about the capacity factor for the offshore wind farm. And so we had talked about what those ampacity studies were, and essentially it's a fancy term for how much current you can push through the before to make sure that it can still be below that maximum temperature. But that's assuming that the wind farms are operating at 100% capacity, 24 hours a day, 7 days a week, 365 days a year. But in reality, it's not going to be like that. So ultimately, what generates heat in the cables itself is the electrical current passing through the cables. So the electrical current will change depending on how much power is being generated. So the actual capacity factor in reality will be closer to 50%, meaning that the cables, the vast majority of the time, won't be operating close to 90 degrees Celsius.
So is it a cumulative heat buildup inside the duct bank and also in the underground electrical vault is my question?
Well, like I said, there's these studies that need to be done. Each cable has current passing through it, which generates heat from each of those cables. And this software is used to figure out the temperature that's being generated for each of these cables and how that affects the overall environment. So including how it's all installed.
The SimCap analyses, the ampacity analyses that I was discussing with this gentleman a few minutes ago, they've concluded that for a sustained 24/7 operation in the dead of summer, the cable temperatures will be 90 degrees or less. And that, again, Mark is 100% right. We don't expect to be at 100% load full time, but the electrical evaluations that we ran did assume that we were 100% load, hot summer day. And with that, the cable core temperatures were 90 degrees Celsius or less. And that's, again, 94 degrees roughly
Fahrenheit, yes. Okay. Something just occurred to me, but it flew through my mind. I'm sorry. I do have a, since you've mentioned a few times the intermittency of the generation, in your PR materials, you say this is wonderful project is going to power 700,000 homes. So should we really think that it's going to power 350,000 homes?
No, I don't know if Ken, you want to address this as well, but that the projected sort of I'm sorry, what's the 50% capacity factor? That capacity factor of what we anticipate the output being from the wind farms over calendar years to come during the service of the project, that's all factored into that analysis that provides that 700,000 homes figure. So that is all based on what we anticipate being the actual output from the wind farm throughout the calendar years of 20 to 25 years of operation of the wind farm.
Yeah, I think the PR materials are somewhat misleading then because they always associate 1,200 megawatts with 700,000 homes. So I just think it's a point of clarification, but may I move on to my general question?
Well, let me just address, though, there is nothing misleading about it. When we got to 700,000 homes, what we did was we took the power that we expected to be generated from the wind farms, we adjusted for the capacity factor, and then we figured out how many homes that power would supply. So that 700,000 already takes into account the 50% capacity factor. So that's an accurate number.
All right. May I ask my general question?
Yes, please.
So as you all know, and those of you who are watching this, my name is Suzanne Conley, and I'm the chair of a citizens group called Save Greater Dowses Beach. And we would like this electrical export landing not to happen at this location. That's what we're fighting for. But we need clarification. We really would like clarification and have been unable to get it. With the release of the draft RFP in the new round of 83C, number 4, it's brought to mind a question. You have your company, I won't say you, but your company has publicly stated that this project is not financially viable, given the contract signed in the spring of 22. And also, there's been a comment that you defaulted on the PPAs. So our question is this, and you've also spoken about rebidding in this new round. Our question is this: if you do rebid, will it be to rebid what essentially will be Commonwealth Wind version 2, or will you be bidding on a new project in one of the other lease areas? I guess I'm asking if you're going to continue with Commonwealth Wind, given the circumstances, and if you rebid, will it be to repeat your bid for Commonwealth Wind? I guess that's one for Ken Kimmel.
Yeah, I'll give it a try. And Suzanne, if I misapprehended your question, just tell me. Our intention is to rebid the 1,200 megawatts of capacity that currently is what was under that contract, the original contract, into the Massachusetts solicitation. And if we're fortunate enough to win, it will continue on the same trajectory in terms of permitting and everything else. And it will be basically the same project with a bid price that's different, obviously, from the original contract price.
That's the clear answer we've been looking for. So thank you, Ken.
Okay.
Thank you.
Thank you, Suzanne. We have someone on Zoom who's had their hand up, so my apologies on that. Suzanne, I'm gonna have
Yep,
you
mute me.
on. Thank you. All right. Carl, you should be all set to unmute yourself.
Okay, can you hear me?
Yes.
Okay, thank you, everybody, for hosting this. This is my first one with Commonwealth Wind. I'm a wind energy advocate on Nantucket Island. I spent 20 years in the Cape Wind Project, and I also worked on Vineyard Wind 1 with Nate Mayo and Rachel Patcher and those folks. Went to Denmark 18 years ago and looked at Newstead in the south and Horns Reef in the west 18 years ago. You don't need to hear a lot about my resume as an activist, pro-wind guy. I had a couple of general questions, if I have the floor for a few minutes.
Sure.
Nantucket Island has 2 undersea cables that are AC cables, 2 substations, one in Harwich and one in Barnstable, and then a landfall at the northern shore of the island, and they go through vaults to the substation downtown. And you probably know this, you folks, you do this for a living, and I don't. I'm an advocate and an activist, but the grid is probably 30 to 50,000 volts on both sides, and they step it up at the stations to 435,000 volts for transport. They lose some in the 26 miles coming over, so it has to be stepped up pretty high. We have to get a third one because the air conditioning is getting really out of control in the afternoons. National Grid has already started engineering a third cable because they're required to by law when the demand is above X number of megawatts, which is 45 to 50 now and going up. The building boom goes on and more air conditioning is going on in July and August in the afternoon. So that's going to cost anywhere from $250 to $350 million, and the ratepayers basically have to pay for it. So I've done some work on the mass resource area, and I've been very active with Vineyard Wind 1. I'm very happy that it's going to be built and is being built. My question is this: I thought that Vineyard Wind had a second lease area, but now I understand from the slide that they're all stacked up, Vineyard Wind 1, Park City, and Commonwealth in one lease area. I was on vacation on the Cape last weekend and I went to the substation. I've been going and checking on it every time I'm over on the Cape because it's like a kid in a candy store. But that substation is going to take all three. Is that correct?
That substation that you saw is just for the Vineyard Wind 1 project. If you're talking about the one in Independence Park in Hyannis.
Correct.
Yeah, that's just Vineyard Wind.
Where's the power going for Park City and Commonwealth? Is that another substation or are they building another one?
There'll be two others. So for Park City, it's at the top of Chute Flying Hill Road, 6 to 8 Chute Flying Hill Road, which is basically right off of exit 6. If you
Okay.
ever take an exit 6 going eastbound, and there's a Cape Cod Chamber of Commerce office and rest area on the exit 6 off ramp, it's essentially right on the other side of the road from that.
Okay.
And Commonwealth Wind is proposed across the street in West Barnstable on Oak Street, just north of Route 6. Across the street from the existing Eversource substation and power lines on Oak Street in West Barnstable. So those will be
Okay,
the three substations.
Okay, so they're both adjacent to the grid and substations, like the one behind Independence Park is right at the grid with the substations there, the infrastructure there. And if you're driving on 6, you can see the power lines at some point near Hyannis Crossing. So I don't have to go into a lot of details about where they are, but I just wanted to know if all three were going to go in that one, but it's probably not big enough, correct?
It's not. These projects each need their own substations. And for Vineyard Wind, as Ken Fitzgerald mentioned a bit ago, the power for those is coming in at 230 kilovolts.
Mhm.
And then there's a substation that's stepping down that power to 115 kilovolts because the Hyannis Tap Eversource substation in that Independence Park area operates at 115 kV.
Uh-huh.
But for our projects, the Park City and Commonwealth ones, the second two, they are plugging into a substation owned by Eversource that operates at 345 kilovolts. So Park City and Commonwealth's electricity come in from offshore at 275 kilovolts. And each of our substations we're building in Centerville and West Barnstable are stepping up the electricity to 345 kilovolts to then plug into Eversource's 345 kilovolt substation. So there's kind of a
Okay.
difference there, but also each project needs its own substation given the amount of power being generated.
And okay, thank you for that. And I'm not going to take the whole rest of the meeting. I just would like the floor for a few minutes. So you're offshore in the lease area. You got a longer distance to the substations. You're using a DC cable, correct? Instead of an AC?
No, all AC. We have all of our runs for Vineyard, Park City, and Commonwealth are all under 50 miles of offshore transmission. So
Okay.
each of the three projects is using AC cable.
Okay, so you have to step them up for transport like our cables because you might lose a little over 40 miles.
I don't know if Mark or Ken, I don't know if they need to be stepped up offshore for AC transmission. I'm not sure.
Well, there's a, and Mark, you should probably backfill the answer, but generally speaking, the the turbines they generate at a certain voltage level in the offshore space, they're stepped up to 275 and
Mhm.
transmitted to shore.
Okay, so the grid within the turbine field steps it up to the substation anyway, then it's sent to shore.
Right, the voltage gets stepped up from the turbines in the offshore substation up to the 275 kilovolt level. It transmits both on subsea cable and upland duct bank at 275 kilovolts. And then, as Pat had said, within the substation, it steps up to 345
Yeah,
to mesh with the local grid.
okay. What else do I have to add? Trying to think of any other questions. This is a really informative way to spend a couple of hours. I'm really learning a lot and I've been in this business a long time. South Coast has got one out there further out from us. They were going to do Falmouth with a substation and they're going to split with a bigger cable going over. They're proposing to go over to Brayton Point substation in Somerset. It's like 110 miles from their wind farm. They're way out. They're in the bottom lease area down there, 23 miles away from us. And you folks are 15 miles from Matticat here. to the first line of Vineyard Wind 1. So that is like a split, one for the Cape and one for Somerset, with a heavy utilities left over at the substation from Brayton Point, which is about 1,600 megawatts or 1,800 megawatts when it was in operation. So they have the infrastructure there to tie in with a 13-inch power line. And I don't know if that's going to be DC. It probably will be if it's 110 miles. But here's another question for you. And you'll know the answer to this because you want to build these wind farms. A few years ago, the utilities, I guess Eversource did it, maybe National Grid was involved, but this is a while back, and I don't know if they were I assume they were in anticipation of future wind farms because of Cape Wind and now the offshore area that the government's done. But they upgraded the power lines crossing the canal between the two bridges. Do you guys know, you must know this, you engineers, can the grid, with the power lines going into the grid from the Cape, are they upgraded enough to handle the power from all these wind farms out there? Because, you know, on a windy day, you're going to have the electrons, the way I understand it, go to the path of least resistance. So Vineyard Wind 1 with 800 megawatts, maybe you can correct me if I'm wrong, but on a windy day, if the average for the Cape and Islands is 230 megawatts, I mean, you're going to send power over the grid, aren't you? And you could juice between New Bedford and Plymouth, a line all the way out to Provincetown with one wind farm. But my question is is the grid on Cape Cod upgraded enough for all the power coming in from the mass resource area at build out, including yours?
Great question, Carl. I'm happy to start. This happens to be a passion area of mine, but if Ken or others want to add in, please do as well. So yes, you're right. Back in, I think, sometime between 2010 and 2012, that additional 345 kilovolt transmission was built over the canal. I believe that's when either the Oak Street substation Edgartown in West Barnstable was either constructed or expanded for that purpose. And that system continues to be expanded and upgraded as part of the Mid-Cape reliability project that Eversource has going on. But the answer is yes, it does. And the ISO New England, our grid operator, has been doing a study of the capacity on Cape Cod, relatively tied in large part to the Vineyard Wind 1 project and the Park City Wind and Commonwealth Wind projects. And although that study is ongoing, the clear answer, as I understand it, is yes. In particular, to another source, if you look at some statements made, particularly by Eversource at its Q1 earnings call back in February, they discussed this explicitly, that on Cape Cod, their system had the ability to take Vineyard Wind's power, the Park City Wind project, and another 1,200 megawatts of interconnection into that system. So that would be the project, basically the 2,800 megawatts of capacity between those three projects that their system could accommodate. But all those, the finalization of that and the studies by the ISO New England Cape Cod cluster study, all is continuing and being finalized. Meanwhile, Eversource is actively upgrading their system, both in Bourne and West Barnstable, to accommodate this power coming in. Anything else, Ken? No, that's good. Okay.
And just to follow up real quick, as you are aware, Brayton Point was probably 1,600, 1,800 megawatts, and Pilgrim shut down the nuclear plant. That was about 650 megawatts. As ISO, they're rooting in power from Hydro-Quebec, lots of gas turbines in New England on natural gas-fired generation, obviously. But is ISO going to say, oh, all right, wait a minute now, we got a lot of potential offshore wind juice coming into the grid. We can replace Brayton Point. We can replace Pilgrim with clean energy. This is the whole idea with nuclear and with coal-fired power plants because of climate change, right? We're all here at the end of the day because of climate change, at least I am, to reduce carbon emissions from electricity generation. I live on Nantucket Island. I'm at the front line of rising sea levels, more powerful storms, and coastal flooding. This is nuts. But can the operators of all these things, and you guys are right involved with all this, are we going to be able to adequately, I think we can, because we're going to have so much power eventually at build out. Can we replace Pilgrim? Can we replace Brighton Point? Can we replace other coal-fired and natural gas power plants in the New England grid with so much power coming from the mass resource area at build out? I mean, we got what, 5 or 6 different companies or whatever. So this isn't really a question, I guess, but I think we can, because I mean, this is the ultimate question. Is there enough power in the mass resource area to juice New England, all 6 states? And they're building in South Fork in Long Island. They're going to build one in the Rhode Island area. I mean, we got some serious power here. So
We do. Ken Kimmel, would you like to?
Yeah, Carl, you make a lot of good points. As you know, Pilgrim and Brighton Point are shut down, and our projects and others like it are going to go a long way towards replacing the capacity that we've lost as coal plants, natural gas plants, in some cases nuclear, shut down. There's an awful lot of wind resource out there in the ocean, as you point out. We have the ability to make a huge dent in our carbon footprint by harnessing that power. We're also going to need more electricity because we need to also electrify transportation and heating. So offshore wind, especially for this part of the country, is an indispensable component towards meeting our climate change goals. I don't think most people think that offshore wind will take care of 100% of our power, but if you look at the Commonwealth's climate plan, it's a very high percentage of it.
and you know, we're talking about capacity factor. I mean, land-based capacity factor might be, I don't know, 20 or 30, but offshore, you're looking at 45 to 50.
Right.
I've lived here all my life, and if you do look at wind maps from Bohm and everything, right south of our island is the windiest place in the Northeast, if not the entire East Coast. The other point to be made is that if you build power, wind power on both coasts, you're close to major population centers of the country. And you don't have to build a long grid to take Midwestern wind power to the cities on the East and West coasts. Right. So if you build wind farms offshore near the load centers of Baltimore, Washington, New York, Boston, Philadelphia, you have to go maybe 50 miles or 35 miles to get the power to where it's needed the most, these big cities. But if they're building a lot of power already in the Midwest for years, but you have to go through this hassle of building transmission to get that power to California from Wyoming, whatever. We all know about this. We read all these magazines and articles online. We're in this business, but why don't we do, and they're looking into floating offshore California. Great idea.
Carl, I'm just going to interrupt a little bit because there are other questions pending, but we're with you and we appreciate your support.
Okay. Yeah, gotcha. Thank you.
Thanks, Carl. Before I go back to any folks, would you like to ask some questions? Anything you would like to ask or comments? You good? Hector, happy to go back to you if you have more questions, and let me just see if Rachel has more folks on Zoom.
I have one very quick one, but I think it's already been answered, so I just want to double check. So we had one Q&A come in from Nathaniel Trumbull, which was speaking to the idea of saltwater flooding in the Dowses Beach parking lot and the submarine cables, which I believe we kind of spoke to in Suzanne's question, but I did just want to, Nathaniel, recognize your question. I'm gonna mark it as answered, but if there was anything you didn't feel was covered there, please feel free to post again in the question.
Okay. Hector, would you like to ask more questions?
So I'd like to come back to the conduits.
Sure.
So I think you corrected me. 9 cables, 12 conduits.
Yes, sir.
Each of the conduits. So does that mean 3 of the conduits, which are pipes surrounding the cables?
Can we go back to that slide?
Yeah. Oh yeah, sorry. Yes.
Thank you.
Yeah, absolutely.
Just walk over here.
Right, you had a good slide up there.
Yes, I'll go to that image. Sorry, folks. Thank you for your patience. There we go.
There we go. All right, so this is the duck bank, the Vineyard One being built.
Okay.
So what happens, and just tell you how it's built, they dig a trench in the ground, these blue walls you see, that's actually what's called the trench box. So you don't need a very wide excavation.
Okay, can I just ask a question? So each of those pipes is a conduit
Each of those pipes is a conduit.
and there's a cable inside of it.
Yes, sir.
But that isn't 8 feet by 4 feet,
It's a vineyard room one. It's smaller for vineyard room one than Commonwealth.
so it's proportionately smaller because there are. Let me do, so there are four conduits and 4 cables, or 6 conduits and 4 cables.
Vineyard wind is an 800 megawatt project.
Right,
So that duct bank has 8 conduit,
okay,
6 active, 1 spare. Okay, Commonwealth wind
okay,
has an additional circuit,
Right.
has 4 additional conduit.
okay. Okay, I'm sorry to interrupt, so.
Yeah, no, it's okay. So anyway, they dig a trench, they lay in the conduit, again, these are 8-inch conduit. These little gizmos here are spacers to get the exact requirement that came out of the engineering electrical analysis. for the
Right.
Spacing and all that, okay? Trench boxes get pulled out, thermal concrete gets laid in, and that's how the duct bank is constructed.
Okay, so the trench box isn't permanent.
It's not, no, that's just a construction.
What is the
mechanism.
trench box made of?
Steel,
Steel.
It's
So
steel.
that gets pulled out and then you're pouring concrete?
yes, you
What,
place concrete, actually.
sorry,
Placing concrete, right?
plates of concrete?
Placing.
So the concrete is already poured, it's already hard when it's put in?
No, the concrete is a slurry. And basically it will fill the excavation. Once the trench boxes are removed, you've got a hole in the ground. You've got the conduit space. Cement truck comes in, pours the liquid, the concrete slurry in to the required height, and it will cure, and then it comes back.
Okay, so I thought that the box, I thought it was a box around the cable conduits, but what you're saying is the concrete gets poured right onto the conduits.
That's correct. Now, every half mile or so, there's a splice vault. That's a lot different. Splice vault is roughly, don't quote me on this, roughly 8 foot by 6 foot, about 32 foot long. It comes in 2 pieces. And it is basically placed in a hole in the ground. And essentially, the splice vault is where the basically will abut the duct bank. So if you're standing in the splice vault on either side, you'll see in the case of Commonwealth wind, you're going to see 12 penetrations on that side, 12 penetrations on the other side. And the cables get pulled through those conduit in the splice vault, and then they become spliced in accordance with manufacturer recommendation.
So the actual length of cable underground is approximately half a mile, and every half mile you need to splice them to the next half mile length of
Yes,
cable.
sir, that's correct.
And why don't you just have the cable be 6.7 miles long and avoid the splicing?
The short answer is that would be a very big cable reel. We've got to be able to ship the cable to the job site, and we're
Right.
limited by the shipping size.
Right,
And the cable rail looks like a spool of thread.
Right.
12 feet in diameter or whatever it's a feet.
okay.
Hector, do you mind if we take 1 or 2 more
No,
questions?
please, go ahead.
So we have one question from Nathaniel Trumbull. I understand that the Block Island project has had trouble with cables becoming uncovered off of the beach at the landfall site.
Yeah.
How will Commonwealth Cable Landfall propose solutions to avoid this problem?
It's a great question, Nathaniel. So the biggest reason that happened, as I understand it from reading the studies on that and talking to some of our colleagues who have looked into that and are proficient in that area. When the cables for the Block Island project were done, they didn't use a horizontal directional drilling technology to basically tunnel the cables deep under something like a parking lot or other infrastructure or mass on Block Island. They dug a trench and they trenched the cables to bring them ashore and then bring them under a roadway. So they dug a huge trench right through the beach where that cable lands. And it seems that the studies they used or their analysis of erosion in that area, either was not done correctly or they didn't do that. So as that area is eroded, cable became unearthed because they didn't trench it deep enough. And in, more particular, they didn't use a technology that's more preferred, like horizontal directional drilling, to get the cable under deeper to prevent an unearthing of a cable. So, and as I understand it, that's what happened here. For our projects, for Vineyard Wind 1 under the Covels Beach parking lot, for Park City Wind under the Craigville Beach parking lot, and Commonwealth Wind under Dowses Beach parking lot. For all three, we're using horizontal directional drilling. Will be 40, 50 feet below the beach, a much greater depths than what Orsted and the community of Block Island did for their cable. And also all the studies we have and consensus information is that these three beaches are accreting beaches, and there's not known or expected erosion at Barnstable's south facing beaches, especially these three.
We do have one more.
Yeah, go for it.
That's right. So this is from an anonymous attendee. Did I hear one of you say that wind power requires beach landings? Since that is conflict number one everywhere you go and lawsuits jam you up, why isn't the industry figuring it out?
So offshore wind does not necessarily require a beach landing. Offshore wind, definitely for its cables, requires landing of the cables somewhere. Another person brought up an area like Brayton Point. Another South Coast Wind is proposing to land cables underneath that facility where there's a substation, where we're proposing to use beach parking lots. The landing of this cable infrastructure is really based on your proximity to a substation where you have the ability and the option to connect that power into the electric grid. For us, where we have the only place in Massachusetts where we have the ability to connect all of this power is at the West Barnstable substation here in Barnstable. So we need landings for our projects in Barnstable, and that is the case for our Park City and the project landing under Craigville Beach, Park City Wind, and for the Commonwealth Wind under Dowses Beach, both are plugging into West Barnstable. For the Vineyard Wind project, they're plugging into a different substation in Hyannis. So really the finding of a location, whether it's a beach parking lot, whether it's a private property, whether it's a commercial property, whether it's some other kind of parking lot, ideally you need something proximate to the coast. And then with an ability to then get that infrastructure under public roadways or other means north to wherever the substation is, you need to interconnect the power. Clearly, given the development and what's available in Cape Cod, beach parking lots with the approval and permission of the town of Barnstable and the Barnstable Town Council have been found by us to be the best solution.
Really quickly, Robert Myers has hand up.
Yeah.
Real quickly, sure. Questions. Oh, it looks like Chris hand down. All right. Oh, sorry, no. Hi, Robert. I just wanted to check. You should be able to unmute yourself now. My apologies. You've had your hand up. I just want to make sure you didn't have any other questions other than those you put in the Q&A.
Sure. Can you hear me now?
Yes.
So, thank you. So Patrick, has the cable been laid under Covell? Is that all done?
That, to my understanding, is done. What they're doing under Covell's Beach for the Vineyard Wind project is done. They are completing, I believe, between now and Memorial Day, the final installation of duct bank and cable on Finney's Lane in Centerville. And they're still working on the substation up in Independence Park in Hyannis. So for the Vineyard Wind project, those are the final pieces. And I believe, according to a presentation from the Barnstable DPW department, there's certain final paving that's going to be done, I think, on McQuacket Lane or one or two of the roadways that's scheduled for the fall. So that'll be the final piece of post-summer Vineyard Wind doing final road resurfacing on a bit of roadways in the town, and they should be wrapping up that Finney's Lane work that's been going on soon if it hasn't already wrapped up.
Thank you. But all the horizontal drilling and cable laying that came in under Covell's Beach is done. Is
Yes,
that
sir.
correct?
Yes.
So I just want to make a comment. I was down there maybe 2 years ago when the substation was being built. Is that likely to be the time frame? 2 years ago?
Yes, for each of these projects, what we're proposing is 2 years of construction during off-season months, similar to what Vineyard Wind did, starting in fall of 21.
So I was down there and I took some pictures of it. And I went down about the end of March, beginning in April sometime. And I was totally confused because I looked at the beach and it looked just like Cape Cod to me. Nothing else. And I thought that the only way that could be is either I completely, they withdrew the project, didn't do it, or they really took care and they went under the coastal bank and they made it so that it still looks just like Cape Cod. And what I took away from that was that there's a lot of challenges, a lot of important things to be covered. But it was clear to me that people doing the work really know what they're doing and they care about what they're doing. And it was very buoying to me to see that. And I came back and told my group of people here in Salem and Gloucester on the North Shore that there were people out there that were doing this work that really knew what they were doing, and they were doing a great job of it. So I just wanted to put that in there. I was so genuinely confused because I couldn't believe it had been put back so well. So I thank you for that.
Thanks, Robert. And I broke up a little bit there, but I think we got most of what you said, and you made a lot of great points there. So I just want to put up on a couple images to what you're talking about, because you are exactly right. This shows you here. Hopefully everybody can see that this shows you what the Cobbles Beach parking lot looks right now. A couple weeks ago, it was fully repaved, relined. All you see is sort of in the back middle of that lot. There's 4 of what's in that bottom right images, these sort of gray looking manhole covers or sort of trench covers. That's all that's left in terms of legacy in the parking lot. They didn't trench, they didn't touch, dig any of the beach. All they did was excavate the asphalt, install infrastructure underneath the asphalt, and then they repaved the asphalt really well, I'd say, and relined it. So that's exactly what we're going to do at Craigville Beach and Dowses Beach as well. And all the legacy will be is those handful of sort of rectangular manhole covers or trench box covers in the lot at grade with the lot. And that's that. So that really shows you what you're talking about in terms of how Vineyard Wind has left the Cobbles Beach parking lot and the entire Cobbles Beach area.
Yes, thank you.
Other questions on Zoom? Or Hector, would you like to ask any more?
A couple follow-ups.
Please go. Yeah.
So back to Ken on the conduits. So as I understand it, and we're talking the Commonwealth project now. The trench that will hold the 10-12 conduits, 9 cables, will be 8 feet, some inches wide, and 4.5 feet high.
Yes, sir.
And once the conduits are laid, that trench will be filled completely with concrete will be poured. So there'll be basically a solid block of concrete, 8 feet by 4 feet.
That's correct. At the end of the day, the conduit will be encased in concrete.
Okay. And you mentioned that there would be splice banks, or what's the term?
Splice balls.
Splice balls.
Right.
Every half mile.
Roughly every half mile.
And are the location of the splice balls in the MEPA filing or in the EFSB filing? So if I wanted to know where on Weano Avenue, for example, would be the first splice ball.
The splice ball locations are still being developed.
Okay,
It's an area we put keen focus on because they do require a fairly large excavation given the
Right.
size of the vaults.
and
So
the size of the vaults they're 32 feet long. Did I hear you say that?
Yes, let me send you drawings, but generally roughly 32 feet,
Okay,
roughly 8 foot tall by about 6 foot wide.
okay,
And by the way, every circuit gets its own splice ball. Okay, and that's for safety.
Okay,
So if you can envision our duct bank is running through the streets.
right,
It has 3 circuits in it. And then what basically happens is we will have a single splice fault for every circuit. So when you take a look at our drawings that will ultimately be developed in detail, is that there'll actually be a bank of staggered splice faults near each other, one for every circuit. And the reason for that is it gives us the ability, for whatever reason, to shut down a circuit and go in, for example, to perform visual maintenance on the cables, the splices, anything else within that, within the vault. We would never send an O&M operation and maintenance person down into a vault that had 72,000 volts of electricity in it. That's
Right.
the reason it's set up that way. The drawings may have conceptually just preliminarily as placeholders shown vault locations, but they are extremely preliminary.
okay,
We want to work that vault locations in close collaboration with the town,
right,
with their source system, and also for what's going on in the area. Trying to obviously avoiding driveways, avoiding places that require access. So that's something that is very specifically dialed in with a lot of collaboration with the stakeholders.
okay. Are the splice faults for Vineyard Wind 1/2 mile apart?
Roughly the same,
And so how many, so they're roughly 10 splice faults?
something along that line.
It's 7 miles
Yeah.
or whatever?
It's if you attending the Park City presentations, the cables get pulled through the splice faults, as we were talking earlier. Literally pulled.
Right.
Grab the end of the cable and using winches, they pull it through.
Right,
And so that there are very strict tolerances by the manufacturer on how much force you could use to pull the cable through.
right,
So if you've got a nice straight run,
right,
you could really, your cable forces are somewhat minimal and you could really space those vaults fairly wide apart.
right.
But if you have
So
a
the
run,
cable segment could be more than 1/2 mile.
it could be,
If it's a straight line.
it could be.
Okay,
The converse is true too. If you've got a lot of bends, particularly sharp bends,
right,
those require a lot of pulling forces.
right,
Faults need to be closer together, much less than 1/2 mile.
right, right,
So
right.
again, Park City Wind, we're getting closer on the locations.
Okay,
Commonwealth Wind, they're a little ways away.
right,
Overall, Commonwealth Wind, design-wise, is approximately somewhere between 15 and 20% complete, so we're very early in the design.
and then concrete versus thermal concrete,
Right.
what is the difference?
The ability to transmit heat is a K factor. Mark, you still there?
Yeah, so I'm still here.
Yeah, the thermal conductivity, that's a unit that pertains to the ability of a material to transmit heat, right?
Yeah, that's correct.
Right.
So we were talking about those ampacity studies before. So
Right.
that's one of the variables that go into those studies is what is the thermal resistivity? And essentially, it's a fancy way of saying how well does the material propagate heat through it?
Right.
So it's a formulation of concrete that allows the dissipation of heat better.
Okay,
So it still has the strength needed that you'd see in conventional concrete anywhere, like the basement floor or
Right.
something like that. But it costs a lot more for thermal concrete because it has those additives that give it that ability
Right.
to dissipate heat.
right. And the heat is dissipated. When you say dissipates outside the concrete,
Right.
what would you call
To
the,
your-
what do you call it after the concrete's been poured? Is that a conduit or
We call it a duct bank.
duct bank?
Duct
And
bank,
it's basically solid concrete with conduits
yes, sir.
encased in the concrete.
Exactly. Right.
So how, on a hot summer day, if the maximum for each cable is 90 degrees Fahrenheit, how much heat do you expect or do you model will be coming out of the duct banks?
Well, we don't, heat is usually expressed in terms of BTUs per
Right.
hour.
Right,
And when we design a heating and ventilation system, that's a very important number, but we address it a little bit differently on the electrical design.
okay,
What we do instead is we basically run those electrical analyses. And the analyses spit out a lot of data. And so for the successful run that we have, we will get an idea of what the cable operating temperature will be, what the ampacity will be, and everything gets passing grade. But then we also have what's called isotherms. It's actually will be a depiction So if you look at that splice, that duct bank drawing that I sent you,
Right,
what will basically be is a series of somewhat concentric circles that will show you the 90 degrees right at the cable core. And then a little bit away, like within the concrete, it's 80 degrees C, then it's 70. And
okay,
it basically establishes the thermal profile around the duct bank.
okay,
And then from there, what we do, knowing what those temperatures are, is we coordinate with the interfacing utility
right,
to make sure that we have adequate separation
okay,
and that there's no detriment either in terms of process fluid or mechanical integrity of piping to those interfacing with utilities, whether they be water, sewer, or gas.
okay. So, and this is, I promise, I almost promised, this is my last question. Where I'm headed with it, so you have this concrete
Duct bank.
duct bank, which is 9 cables or 12 conduits encased in concrete. And it's 8 feet by 4 feet, round numbers.
Yeah.
You have other utilities under the road.
Yes,
How close will the natural gas pipes be, or are they in pipes? Is the natural gas transmitted in pipes?
generally speaking, yes, the utilities are in pipes to what we call direct buried. They're not in any kind of duct bank. They're just buried in the earth.
Okay, and the natural gas is transmitted or is flowed through copper pipes?
There's different pipes that are used. They use, I don't believe copper is one of them. They use steel. They do use HDPE. Excuse
Which
me,
is a plastic.
high density polyethylene.
Okay.
Yes, sir.
So what have you encountered in Barnstable?
There's a lot of utilities.
Yeah.
And it's a very close collaboration. Commonwealth
Right.
wind isn't quite there yet.
Right,
But,
but for Vineyard Wind, the natural gas pipes are underneath the road with their conduits. What are those pipes? What is the material for the natural gas pipes for Vineyard Wind?
I'm afraid I don't know
Okay.
that, but I can tell you what we're doing on Park City and Commonwealth
Okay.
specifically.
Okay.
For Park City's a little further along, so when we talk about
Yeah,
that
yeah,
process, it'll be the same.
Right,
With the duct bank design,
Yeah.
what we call the isotherms, the underground utilities get evaluated. And so in the case of water is a good example. Avangrid working with Stantec and other consultants, coordinating back with the local water companies
right,
to look at those profiles and determine what needs to be done.
right,
And in the case of water, one of two things, or both things could happen. We either have to move the water main a little further apart. Of course, we've made every effort to get as much separation as we can, or they need to be insulated. And so that's a collaboration. It gets agreed to in collaboration with the interfacing utility. Natural gas is a little bit different because that's owned by National Grid. They perform that analysis on their own using the inputs that are provided by Avangrid, the isotherms, and they will decide what has to happen to the pipe, whether the pipe needs to be moved away, whether the material needs to be changed, or whatever else, and they will do all the construction.
What would you say is the average distance between a National Grid pipe and a concrete conduit in Vineyard Wind or Park City Wind?
You know, it greatly varies. I'm
What would
afraid.
be the shortest? Would it be a couple of feet or would it be 10 feet?
We'll have to get back with you on that.
Yeah.
I don't even want to venture a guess. Yeah, I wouldn't want, I wouldn't want to venture a guess. That's something I've not looked at personally.
Yeah,
But my
okay.
team has.
I'll write that
We-
down.
we have-
We'll add that to our-
We have some more after if you
Yeah.
don't mind.
Yeah, so that concludes my questions. Thanks very much.
Thank you.
Thank you.
Another question from Nathaniel Trumbull, after decommissioning of the project in 25 to 40 years, will the duct banks and cables be left under the roads?
It's a good question. So the way that is addressed, I believe, by our federal permitting at the BOEM level is decommissioning. We're gonna for over the years of the lifetime of the project, we're gonna pay into as part of the project into a decommissioning fund, which will fund the decommissioning of the project, particularly if the decision was made to not repower the project, to not put out new state-of-the-art turbines, replace the cable, put in new cable, et cetera, that there'll be a fund to pay for that decommissioning of the infrastructure. The standard that the Bureau of Ocean Energy Management, the federal level, has for that is that decisions on decommissioning would be based on what had the least environmental impact, of whether leaving certain parts of the infrastructure offshore or onshore made the most sense, or whether removal of it it had the least environmental impact, removal or keeping in place. So you could envision maybe the bottom foundations of the turbines at the seafloor, where artificial reef and other habitat has been created, that BOEM might say it's an environmental interest to take out the towers of the turbines, but leave the bottom infrastructure that's being well utilized by the marine ecosystem in place. That would then extend to decisions of removal of infrastructure within the town of Barnstable, would all be guided by that same process. That's the permitting level that I'm familiar with that would cover that decommissioning. But I don't know if Ken Kimmel, I know Christina's not on. I don't know if there's anybody else from the permitting team who would have any other contributions to that discussion.
Pat, I think you generally covered it.
Good. But I think in all honesty, Nathaniel, it's very likely, given where our country is going on renewable energy generation, that repowering and that these wind farms and areas in all likelihood will continue beyond the lifespan of this project. But certainly the Bureau of Ocean Energy Management and other state authorities will potentially look at that further if it becomes an issue in future decades. Any other questions in the chat?
Maybe I'll just jump in there quick, Pat, if that's all right. I had responded to a question a little bit ago about the saltwater ingress into the vault. And I'm not sure if it was totally clarified. So I just wanted to reiterate that for those cables, they will be designed for being able to be submerged fully within water. Including the joints, those field splices as well. So I just wanted to throw that in there just in case.
Thank you, Mark. So we got another question here from Nathaniel that I'll read. Will there be any visible signage above the road identifying the cable route after completion of the cable installation? That's a good question. I believe Ken Fitzgerald or Mark, you might want to add to this, that is not a requirement for either the Vineyard Wind project or either of these projects, that because of the high quality and installation of this infrastructure, it will not be required by the state for there to be any high voltage infrastructure below or any types of flags or other signage to that effect, that is not going to be necessary. And so to my knowledge, for both the Vineyard Wind project, which is now kind of completing its infrastructure installation, and for our projects, any type of above ground signage is not planned, and my understanding is deemed not necessary by the relevant state authorities. Anybody else in the room? Well, I think otherwise, thank you all for such a great meeting, and maybe one last one. Well, thank you for the very informative webinar. Thank you, Carl. Nice to hear from you. All right, well, thank you all. Hope you have a great evening, and thanks for coming out. And everyone on Zoom, have a great night. Okay.
Thanks. Sorry, I just want to stop the recording.
So Hector, I have 3 questions.